Hello friends, welcome to the world of discrete mathematics with me Kunal Airi on my YouTube channel. Here we are going to learn about the concepts of discrete mathematics. Let's start with the new chapter of discrete mathematics is mathematical induction. So in mathematics, many times some results are guessed by observing some patterns and then prove or disapprove. So here in this chapter, we are going to solve the results associated with the natural numbers. Means we have to show that the results are true for all natural numbers. For example, if you consider any sequence that is 1 plus 2 plus 3 plus dot 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 plus n, that is the sum of first n natural number is equal to n plus 1 upon 2. So we have to prove by using the mathematical induction this sequence is true for all natural numbers, and this method of proving such results is nothing but the principle of mathematical induction. Means we have to prove for all natural numbers. So principle of mathematical induction, there are three steps. The step number 1 is basis of induction. Now basis of induction means we have to prove for p of 1, that is n is equal to 1. Okay, this is the step number 1. Now step number 2, induction step, that is we have to assume that p of k is true for some k belongs to capital N. That is the step number 2, induction step. That is assume p of n is true for n is equal to k. Now the third one is induction hypothesis, most important step. For the step number 3, always remember कि आपका step number 2 यहाँ पे use होने वाला है. So step number 3 is to prove that p of n is true for n is equal to k plus 1. Means we have to prove for p of k plus 1. If these 3 steps are true, that time we said that the conclusion means p of n is true for all natural number, that is n belongs to capital N. Now for the mathematical induction, always remember if there is a sequence, okay, अगर sequence है तो आपका p of k plus के लिए आपका एक term add होगा like this 1 plus 2 plus dot 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 plus. अगर if the last term is k, that time what is k plus next term k plus 1, that is a k plus 1. And if there is a constant term, that time we have to replace k by k plus 1. So this is principle of mathematical induction. Step number 1, basis of induction means we have to prove for p of 1, that is n is equal to 1. Step number 2, induction step, we have to assume that p of k is true for some k belongs to n. And step number 3, most important step, we have to prove for p of k plus 1. Now for the step number 3, कौन सा step हम लोग यूज करने वाले हैं? Step number 2. विदाउट स्टेप नंबर 2 हम लोग स्टेप नंबर 3 सॉल्व नहीं कर सकते. अगर ये तीनों स्टेप्स आपके ट्रू आ रहे हैं, मींस वी कंक्लूड दैट p ऑफ n इज ट्रू फॉर ऑल नेचुरल नंबर्स. एंड 2 पॉइंट्स, इफ देयर इज अ सीक्वेंस दैट टाइम वी हैव टू ऐड वन एक्स्ट्रा टर्म. अगर कांस्टेंट टर्म है तो दैट टाइम वी हैव टू रिप्लेस k by k plus 1 फॉर द स्टेप नंबर 3. नाउ लेट्स स्टार्ट द एग्जांपल्स. By method of induction, prove that 1 plus 2 plus 3 plus dot 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 plus n is equal to n plus 1 upon 2. That is the sum of first natural numbers. Let p of n be a statement. What is the statement? 1 plus 2 plus 3 plus dot 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 plus n is equal to n plus 1 upon 2. So this is the statement. Now we have to prove for all natural numbers. So step number 1, that is basis of induction. So what is basis of induction? Prove for p of 1, that is n is equal to 1. सो सीक्वेंस में से आप लोग अगर p ऑफ 1 अगर कंसिडरेशन करें मीन्स फर्स्ट टर्म, p ऑफ 2 अगर कंसिडरेशन करें मीन्स एडिशन ऑफ फर्स्ट 2 टर्म्स, p ऑफ अगर 3 कंसिडरेशन करें तो एडिशन ऑफ फर्स्ट 3 नंबर्स. यहाँ पे p ऑफ n है मीन्स व्हाट इज द टर्म n. सो वी हैव टू प्रूव फॉर p ऑफ n. तो n का वैल्यू कितना ले रहे हैं हम लोग 1 ले रहे हैं. सो टेक LHS. व्हाट इज LHS? n. नाउ पुट द वैल्यू, वी गेट 1. इक्वेशन नंबर फर्स्ट. नाउ RHS. What is RHS? RHS is equal to n plus 1 upon 2. Now put the value, n is equal to 1 plus 1 upon 2. So we get here 2 upon 2 is equal to 1. Now from equation 1 and equation 2, right? From 1 and 2, we said that LHS is equal to what? RHS. Therefore, P of 1 is true for n is equal to 1. So this is step number 1, that is basis of induction. Now step number 2. Induction step. Now for the induction step, we have to assume that P of k is true for some k belongs to capital N. Therefore, 1 plus 2 plus 3 plus dot plus n is replaced by k is equal to k plus 1 upon 2. Equation number 3rd. So step number 3 के लिए आपका ये सबसे important step है, that is a step number 2, induction step. Now go for step number 3rd. Induction hypothesis. Now induction hypothesis means we have to prove for P of k plus 1. That is, we have to prove 1 plus 2 plus 3 plus dot plus k. Now this one is a sequence. तो sequence है तो हम लोग k plus 1 क्या करेंगे, term add करेंगे, right? Is equal to, now on RHS constant term है तो k is replaced by what? K plus 1. Then k plus 1 plus 1 upon 2. So you have to prove that LHS is equal to RHS. Now take LHS. LHS क्या है आपका यहाँ पे 1 plus 2 plus 3 plus dot plus k plus the last term is a k plus 1. Now see this term from 1 to k, from this term to this term. Yeah, आपका step number 2 है, right? That is the induction step. So this term is equal to what? From equation number 3rd, k plus 1 upon 2, then plus k plus 1. Now perform the cross multiplication. We get k plus 1 plus 2 k plus 1 upon 2. So is equal to, now k plus 1 take as a common term, remaining value k plus 2 upon 2. So equation number 4. Now take RHS. What is RHS? K plus 1 plus 1 plus 1 upon 2. So is equal to, we get the same term k plus 1 k plus 2 upon 2. Equation number 5. So therefore, from equation, which equation? Equation number 4 and 5. We said that LHS is equal to RHS. Therefore, P of k plus 1 is true. So at the last, therefore, by the principle of mathematical induction, the result is P of n is true for all natural number. Therefore, P of n is true for n belongs to capital So this is considered as a principle of mathematical induction. So how many steps are there? 3 steps. The first one is a basis of induction. Proof for P of 1, that is n is equal to 1. Step number 2, that is a induction step, where do I assume that P of k is true for some k belongs to capital N. And the third step, induction hypothesis, that is proof for P of k plus 1. So यहाँ पे स्टेप नंबर 3 के लिए आपका ऑलवेज कौन सा स्टेप यूज होने वाला है? स्टेप नंबर 2 यूज होने वाला है. ओके, और यहाँ पे ऑलवेज रिमेंबर 2 पॉइंट्स. द फर्स्ट वन इज दैट इज अगर सीक्वेंस है तो वी हैव टू ऐड वन एक्स्ट्रा टर्म, राइट. एंड अगर वहाँ पे कांस्टेंट टर्म है तो हम लोगों को k किससे रिप्लेस करना है? k plus 1 से. नेक्स्ट लेक्चर we see the examples related with the same topic, that is principle of mathematical induction.
If you like my video, then like it, share it and subscribe to my YouTube channel. For the more videos related with the discrete mathematics, don't forget to click on the bell icon button.